Today's video is in your new Unit 1E Proportional Thinking packet. So it's on page 1, the problem of the day. Alex helped out at his family's business over the summer. He was hoping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. Alex wonders, if I continue to work and earn money at this rate, will I have enough money to buy the gaming system by the end of the summer? To check his assumption, he decided to make a table. He entered his total money earned at the end of week 1 and his total money earned at the end of week 4. So key words there, at this rate. Well, rates are a comparison to 1, and here's our 1 right here. In 1 week, he earned $28. Is that the same rate if he worked 4 weeks? So is 1 to 28 going to be the same thing as 4 to 112? Well, I could check it this way. I could set up a proportion and say, is he still earning $28 per week? So I could cross multiply, right? Product of the means, 28 times 4 is 112. Oh, yes. And 1 times 112 is 112. Another way I could do it is take 112 and divide it by 4. And yes, 2 times 4 is 8. And when you subtract, you get 32, right? And when you do times 8, you'll get that 32. So I could divide 112 by 8 and see that, yes, he's still earning $28 per week. That's his rate. Knowing that it's $28 per week, go ahead and fill in this table. And he hasn't worked anything 0 weeks, so obviously he has 0 money. Fill in the rest of the table with the rate of $28 per week. He wonders, will I have enough money to buy the gaming system by the end of the summer? And then answer question B. And we'll go over this in class. So pause the video and answer the first page. On to page 2, understanding direct proportion. So identifying a direct proportion from a table. This is in the 7th grade book, chapter 5. So 7th grade text, chapter 5. So we're in the green textbook online, talking about rates and the constant of proportionality, direct proportion. At a supermarket, each pound of strawberries costs $2. So strawberries are $2 per pound. That's the rate, the unit rate per 1 pound. So 2 pounds of strawberries cost 2 times $2, which would be $4. And 3 pounds of strawberries would cost the rate of $2 times 3, $6, and so on. The table shows the cost Y dollars for X pound of strawberries. So the cost depends on how many pounds of strawberries you buy. As the cost increases, the weight increases. Or as the weight increases, the more pounds you buy, the more it costs. Notice that what happens when you compare the cost of the strawberries to the number of pounds. So $2 a pound, notice that it's the Y on the top and the X on the bottom. That's important. $4 for 2 pounds and $6 for 3 pounds. They are all the same rate. They are equivalent. They are equal to $2 per pound. So you read the proportion 4 is to 2 as 6 is to 3. The ratios are equivalent because in each ratio the first term is 2 times the second term. These rates can be associated with the ratio of 2 to 1, 4 to 2, 6 to 3. An equation that says that 2 ratios are equivalent, and can't see this very well, is called a proportion. And we know that because we've been doing proportions. That's that word there. 2 to 1, is to 4 to 2, and 4 to 2 is as 6 to 3 are examples of proportions. Next page, you can see that the cost of the strawberries is always 2 times the number of pounds. The cost of the strawberries and the number of pounds are said to be in a direct proportion. If you let y equal the cost of the strawberries, because that's a dependent, the cost depends on how many pounds you buy. Y is always the dependent variable. That's a thing to know there. Y is the dependent variable. I'm going to introduce that right now, so please write this in. And X is the independent variable. And yes, it's related to our graph, the Cartesian plane, that has an x-axis and a y-axis. When we graph things just in the first quadrant, the dependent variable goes on the y-axis and the independent variable goes on the x-axis. Y over x equals 2 and y equals 2x. So when you compare the cost of the strawberries and x be the number of pounds, you can write 2 equivalent equations. Every time the cost divided by the pounds, the cost divided by the pounds came out to be $2. Or to find the cost, take the pounds and multiply it by 2. So if y over x equals k, a constant, and y equals kx, where k is a constant value, then y is said to be directly proportional to x. The constant value k, going to be important that you remember that, it's a k, in a direct proportion is called the constant of proportionality. So k equals the constant of proportionality. Just like our rate of speed with our formula with 3 variables, distance equals speed times time, we can relate this proportional relationship y equals k times x, and yes, y equals kx, and k, if we're trying to find k, k is equal to y divided by x. So that little triangle is going to come in handy. Jim walks 900 meters in 5 minutes. At what rate does he walk? So it's asking me his rate of speed, his rate of speed. And when I taught this to you, yes, I sometimes make that triangle with distance equals rate times time. Well, rate of speed, we can call it an R or an S. So doing it through the bar modeling unit way of doing it, well, if in 5 minutes he can walk 900 meters, right? 5 minutes he walks 900 meters. Then to get 1 minute, I would divide 900, divide it by 5, and I would get, oh, that he walks 180 meters. So Jim walks at a rate of 180 meters per minute. Taking my distance of 900 and dividing it by my time of 5 minutes will give me my rate of speed of 180 meters per minute. Probably better if I don't put that P in there because that's miles per hour. Meters per minute. That's a better way to label that rate. Meters per minute. Here it is as a SABLE. Sentence answer box label. Full sentence answer there. I like that SABLE. Next page. Proportions, proportional relationships. Example 1, pay by the ounce frozen yogurt. Oh, how many of you have been to Yummy's, right? Right here in Fairport, the frozen yogurt place. You get a bowl, you fill it up, you put all kinds of yummy toppings on it, and then it costs you a fortune. Anyway, a new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of the yogurt and its toppings, just like Yummy's. Each member of Isabel's family weighed their dish, and this is what they found. For 12.5 ounces, it was $5, one person. Maybe that's Dad. Mom had 10 ounces, which cost $4. Little Timmy had 5 ounces, only cost $2. And you, Isabel, got 8 ounces, and it cost $3.20. Compute the constant of proportionality. So is my cost y proportional to my weight x? So I am going to do y divided by x, cost per ounce. To find the constant of proportionality, I want to know, do they all have the same rate, cost per ounce? So $5 divided by $12.50, well, that equals 40 cents per ounce. $4 divided by 10 ounces, well, that's also 4/10, 40 cents. I guess I could put the 0 on there, per ounce. $2, 2/5 is the same thing as 4/10, so I know that's 40 cents per ounce. And $3.20 divided by 8, well, 32 divided by 8, I know that's a 4, so 40 cents per ounce. So compute the constant of proportionality. You have to do all 4 of them to be sure that this is a proportional relationship, because sometimes one of them doesn't come out to be the same. So here, K equals 4/10 or 40/100. Write an equation in the form of y equals, okay, my y, my cost, equals the constant k, y equals kx. Well, plug in what I know k is. It's 40 cents, x times the weight. 40 cents for every ounce. That will figure out my cost. Here's another example. A cooking cheat sheet. In the back of a recipe book, a diagram provides an easy conversion to use while cooking. Compute the constant of proportionality. Write an equation in the form of y equals kx to describe this situation. So part A, compute the constant of proportionality. Well, I know right here, here's my y ounces and here's my x cups, because there's my 1. That's the unit, like unicycle, UNI means 1. There's the unit rate. Whenever my x value is 1, that's my unit rate. So I know that 4 divided by 1/2, oh, keep it, change it, flip it, 4 times the multiplicative inverse 2, oh, that equals 8. 8 divided by 1, that equals 8. 12 divided by 1.5, well, that's 12 times 2/3, oh, I better do that. 12 times 2/3, oh, 3 goes in there 4 times, oh, that's 8. Remember, multiplicative inverse. And 16 divided by 2, that's also 8. So they are all constant. The constant of proportionality is 8. K equals 8. Yes, there are 8 ounces in 1 cup. That's what it's saying. 8 ounces per cup. And that's true. When you're measuring things, 8 ounces is a cup. Write an equation in the form of y equals kx. So my ounces, y, equals 8 times my cups, x. So if I have 4 cups, for instance, if I have 4 cups, oh yes, I have 32 ounces. That makes sense. 4 cups, 4 times 8 is 32 ounces. So that does work. Y equals 8x. Example 3, pitches thrown by inning. The table shows the number of pitches made, y, so the pitches, in x innings of a baseball game. So in inning 1, the pitcher threw 15 pitches. Oh, somebody must have gotten on base. Or somebody kept fouling it off a bunch of times. We're not sure. 15 pitches in the first inning, 30 pitches in the second inning, 50 pitches in the third inning. Wow. Compute the constant of proportionality. So y divided by x. It's always y over x equals k. So my bottom number here, y, has the pitches, has the y on it. So 15 divided by 1, that's 15. 30, divided by 2, that's 15. 50 divided by 3, that's not 15. That's 16, 48 and 2/3. There is no constant of proportionality. There is none. It's not constant. It's not 15 every time. That's a problem. Write an equation. Well, we can't because we don't have a k, so there's no equation. Can't answer that one. And we'll see other problems like this in class tomorrow. We're going to practice y over x equals k and finding the constant of proportionality. That's it for today's video.